Hello, my name is Steven. Welcome to Highfinder Tech Talks, where we try to understand the technology behind the hydrogen economy. Mobile EV charging is our topic for today, and that's really an interesting one. I'm also very delighted that today we're able to link up to someone who's been very innovative in that field, a gentleman who's worked for several years in a company on another country in the Czech Republic, and who has developed very innovative solutions and with whom I will deconstruct this topic today. So I'd like to give a very special welcome to Jiří Vršinský. Hi, Jiří.
Thank you.
I hope I got your name
hello.
right.
Hello, everyone.
Yes, hi, Jiří. So, Jiří, you are connected to us from the Czech Republic. Can you tell us where you are standing? Where are you now?
I'm in Jablonec nad Nisou, so that's a sort of a north of Czech Republic, in our workshop where we are conducting a hydrogen applications development and also some charging development, battery development, and so on.
Yeah, okay. Well, so directly in your workshop where you do all the work, and we already see something behind you. I think we'll come to that in a few minutes, so please hold on to that. Now, overall, mobile EV recharging, I mean, just to get to this, like, why would anybody even want that? Most people know that they need to drive their vehicle up to, let me say, a socket or something and then charge a vehicle. Can you take us a little bit onto mobile EV charging and how you guys got to that?
Yeah, okay, so I guess you said it correctly. So most of the people will always drive to socket or a, let's say, static charging station or a standard charging station, which is connected to the AC grid. However, we still see some use cases where some special charging application can be used. It can be either for saving the cars if they are stranded out of battery power. It can be in the blind spots. So I'm not sure if you see the presentation, but for example, in Czech Republic, there are still some blind spots where you cannot charge your electric vehicle. It can be because of the AC grid limitation. So not everywhere is enough power to charge the electric vehicle very quickly. And of course, we also aim on some special applications. So if you, for some reason, need a charging station on some remote place or some special place where normal charging station or static charging station is not available, you can potentially use one of our solutions. So.
Yeah, I mean, we see that you have that presentation with the pictures on it, and yes, I can tell you that there are. I'll say most of the world is a blind spot in terms of charging. If you look at the entire world and the oceans or whatever world. So I think that from there alone there comes a case to it. However, I hear from many people that charging in itself is complicated. So that it's an entire process. Can you take us a little bit into what it actually takes to charge a vehicle, and also what you do when you do that with hydrogen?
Yes, on the first glance, it seems kind of straightforward. So you connect either AC power, and then the vehicle converts it to the DC and charge the battery, or in most cases, I guess today, you connect the DC power to your most likely CCS socket. So that's a standard every electric vehicle use right now. And then you supply the DC power directly to the vehicle. There are two, let's say, layers or two kind of components involved. There's some kind of communication unit or some kind of communication interface, which tells the vehicle how much power, how much current, what voltage can the charger provide, and then the vehicle tells the charging station how much power, what current, what voltage does the vehicle require. So that's the communication side of the things, and then there is some power electronics which converts the either AC or DC to the to the power the vehicle requires. So it's an AC-DC converter converting the AC power from the grid, or DC-DC converter converting any kind of DC power to the DC current vehicle requires. So those are the main, let's say, components of the charging station. Of course, there are others, but I think that's a little bit on the technical detail.
Yes. And when you want to do this now with hydrogen, I guess something comes on to that.
Yeah. So if we want to charge the vehicle with the hydrogen, we always add a fuel cell. There is a way to control the fuel cell, which utilize the DC-DC converter. So we add some DC-DC converter for the fuel cell, and there is usually a battery involved. By battery, it's because the fuel cell cannot react quickly enough for the change in the vehicle requirements. It's most important is it is in case the vehicle suddenly stops the charging session, disconnects the charger itself, then we are running the fuel cell on full power. We need to dissipate the energy somehow. So we have the battery to take care of that. Also, the battery provides power for the peaks, and it's also possible to use the battery to increase the immediate charging power. So, for example, in our applications, we are usually starting with a full battery. So we start charging with a higher power, and then if the battery is depleted, we only have the fuel cell power, and we decrease the power for the vehicle. So it can be also used like this.
Yes, I know.
Then there is.
Yes, sorry, please go ahead.
Also, a little bit, little extra job for the main control unit, because all the components have to be managed somehow. We call it usually the power management. I don't know if it's like official term or if we just make it up, but we call it power management, and that takes care of the battery SOC, vehicle SOC, all the DC-DC conversions, fuel cell, hydrogen storage, and everything.
Yeah. So okay, you counting on those devices which you mentioned. So you have the battery SOC, the fuel cell, the vehicle that you're charging. You've had the hydrogen tanks that you fill. So there's really a lot of controls going into that. I know that. I mean, you work at Devin, and I know that you guys have been quite innovative in this. So did you go straight to building something like the product at the back, or did you go some steps before that way?
Yeah, there were some steps. So Devin was always interested in electromobility, and we were thinking what kind of project we could do to support the electric mobility. And back then, the cars usually didn't have the range of 4,400 kilometers or something like that. So we were thinking, okay, we will do this this aid vehicle, let's say, so this support vehicle that can charge a standard car. Originally, we thought, okay, we make it with a lot of batteries, but then we have calculated the batteries would be too heavy and would not have enough energy. So we somehow got an idea to build this vehicle with a hydrogen fuel cell. So what we did, we integrated hydrogen fuel cell, the DC charging station, the hydrogen cylinders, and all the other stuff needed by the fuel cell into the passenger car. It was a plug-in hybrid vehicle, so we utilized the battery of the plug-in hybrid to stabilize the power of the fuel cell. And this was our first hydrogen fuel cell project. On the beginning of the project, we thought it will be really simple, just like you connect the hydrogen on one side and the power outlet on the other side. Yeah. And we learned it's much more difficult, but in the end, we managed it somehow. We make it work. It worked for some times. Now it's at the customer, so it's out of our hands. But after this project, we have said, okay, it was nice, but now it's at the customer, and we can do nothing with it. So we came up with another project which was basically the same thing, but it was not integrated into the vehicle. We call it H2 base. And to make it simple, it's like it should replace the petrol or diesel generator with a hydrogen fuel cell and DC-AC converter. But since we also had experience with the charging station, we also added DC charging stations for electric vehicles, and we also added possibility to use the heat, the waste heat from the fuel cell. So the fuel cell produced a lot of heat. It's about a 50% efficiency. So if you have a 30 kilowatts electric output, you will have 30 kilowatts or more heat output. So you can also use the heat to heat whatever you want. Yeah. So yeah, that was our second project, which is right now ready, and we offered to our customers. And then when this was finished, we were also thinking, okay, what to do next, because the hydrogen fuel cell applications, we really enjoy them, and it's interesting work. So we came up with another fuel cell application, and that's the application you can see behind me. It's we call it H2Bot. It's a remotely operated hydrogen fuel cell charging station. The idea behind this is that it can drive around the parking lot and charge electric cars. So instead of using a couple of or many stationary chargers, you can use this remotely operated vehicle, let's say. You can see it behind me. I'm not sure if you want to see it a little bit.
Yes, actually, I would love to. But before you go there, I want to ask you something. So that vehicle, how much energy does it contain, and how many vehicles can you? I mean, we can be walking over to there, but still, as we talk, how much energy is in there?
Okay. Right now there is 14 kilograms of hydrogen. So it's around 230 kilowatt hours of a charging energy, let's say. So it's like 2 and something Teslas, or I don't know, the one of the large electric vehicles. And then you of course have to either fill it up, or you can exchange. It contains the cylinder bundle, and you can exchange that if you want. I will just show the pictures, because the cylinder bundle is not inside right now. You can see this is the picture from the testing the cylinder bundle.
Oh yes.
So we have to do the kind of a flip test if it doesn't get damaged. And maybe I can show you a little bit.
Yes, please. Yes, please. We are very curious. So these cylinder bundles will actually go into this vehicle.
Yeah, it actually goes into the vehicle. I can show you. It goes here in the. I hope my colleague can keep up.
Yes.
So it actually goes here in the middle. You can see the gap there.
Yes.
In this particular workshop, we cannot have the cylinder bundle installed because there is no ventilation, which is required in case some things go wrong. So in the middle there is a cylinder bundle. It can be exchanged with this manipulation device. It's not exactly the forklift, but yeah, something like a small forklift.
Okay.
Here, I will wait for my colleague. Here on the rear side, there is this robot. It has the 3D camera, and it has the charging socket. The operator has to move the robot in the way so he can see the charging inlet of the electric vehicle, but the connection itself is done automatically. Then here in this section, there is a battery and all the DC-DC converters, the charger, the control units, and so on. And in the back, we have the fuel cell with the cooling system. I can show it a little bit. Hope you can see it. It's a little bit dark in here. So yeah, this is the fuel cell. On the top, there is a cooling system.
Yes.
And in this project, normally we would use the heat to heat something up, but here we don't have any.
Yeah.
cannot
How
utilize
big is
the
the
heat. So
fuel
we just,
cell system? What power does the fuel cell system have
yeah,
that you have in
the
there?
fuel cell has a 60 kilowatts right
60
now.
kilowatt, yeah.
The charger is now 45 kilowatts above. We can increase the charging power, on the step of 45 kilowatts, but then we would have to use the more powerful fuel cell. So, so this is what it is,
Yeah.
and it works quite well. It's now on the. It should now go to the customer to make like a prototype test, and we'll test charging the different electric vehicles. We'll test if it's connecting properly.
As we see the robotic arm at the back, so that actually can by itself connect to a vehicle, or so it
can open the charging socket.
Yes.
If on one condition, if it's not locked,
Okay,
because
yes.
the vehicles right now, they don't expect anyone to connect the charging cable without the owner being present.
Yeah.
So at our customer, it's not problem. They can leave the vehicles unlocked, but and in the parking lot, you cannot really imagine all the vehicles being unlocked. But we can not do anything about this. It's more about the vehicle manufacturers.
Yeah.
We are in discussion with some of them, and they know in the future this problem should be addressed somehow. But right
I mean,
now,
well, that is clearly a case of dialogue, of interfaces. I mean, if the robot can somehow authenticate itself as being legit, then that would one way work. Yeah. I'm also thinking about rental car manufacturers who may have a fleet of cars standing around, and they can leave them unlocked if they're in a parking lot or so, and then have the robot take care of the charging over the night.
It's also possible.
Yeah.
It makes sense, especially where the AC grid is not powerful enough.
Yes.
Because of course it has some disadvantages. The price of the hydrogen, the efficiency of the whole system. You have to take those into account. But we still see some use cases for this. So and also there is not many companies dealing with this kind of with those solutions. So
and I mean overall, if the price of hydrogen goes to a range where it's quite competitive, I think you will see quite a delta here. Overall, this is amazing what you're doing. I think it's really at the forefront providing these kind of solutions. That's the one thing, to actually have the courage to also do that. So this is really good. I know that you, as an electrical engineer, you're passionate about this. You've been into racing and all these kind of things. So I just want to say good on you guys and your team. Thank you for taking us into this product and what you're doing for mobile EV charging based on hydrogen. This is very interesting.
No problem. Yeah.
Unfortunately, we have actually come to the time that we have for this video. So I think you've now given us some good taste of what's to come.
Okay. Yeah.
Can you tell us what's going to be the next project, or that's top secret probably?
Well, I don't think it's top secret. It won't relate to the hydrogen charging, but we're also building a hydrogen fuel cell truck. So that's one interesting project. For one customer, we will also build sort of a hydrogen. I'm not sure right now if it will be only AC outlet or if it's also be the charger. So something like H2 base, so similar module. Mm-hmm. And since the hydrogen development, it's moving really fast, and the fuel cells at higher and higher powers and higher power density, we are trying to integrate the more powerful fuel cell into the smaller package right now.
Okay, cool. Well, and I understand you don't make fuel cells yourself. Exactly. You actually source them and then put them in there, which is an ideal link to actually Highfinder, because on the Highfinder platform you can find these products, like something that you've shown, also the link to yourself, but also fuel cells systems that you guys can put into such systems and many other things. So that's for everyone interested in hydrogen economy. Feel free to use highfinder.com. If you like this video, please subscribe or give us a thumbs up in some way, form or another. Give us some nice lines on LinkedIn or wherever you are. Also, feel free to look around for any other videos which we will be making in this series. We hope that you've taken something with. I've certainly learned something. Thank you very much, Jiri, for your time and taking us into your workshop, which I think not everyone can get to see like that. Thank you so much. And I wish you more success for all the projects that come. And hopefully we shall be dropping our vehicles off somewhere and then we'll have all these robots fill them up. And we won't need to worry about that. Yeah. Thank you so much. And everyone have a good time still. Thank you. Goodbye.
Bye.